Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of scalar and vector projections. So let's start with part A. The vector A is projected onto the x-axis. What is the scalar projection? What is the vector projection? So let's start with part A. Vector is projected on another vector when they are arranged in tail-to-tail format. So the first thing we can do is to draw a diagram for this problem to understand the projection of vector A on the x-axis. Now vector A is equal to 2, 3, so it can be the position vector for point 2, 3. And point 2, 3 is in quadrant 1. So it can be somewhere here. So this is vector A. Now we have to find the projection of vector A onto the x-axis. So we have to write a vector for the x-axis, and it can be position vector for a point on the x-axis. So it can be 1, 0, 2, 0, 3, 0 or any other number. We'll have to use the positive x values because this vector A is in quadrant 1. So let's use the smallest or easiest possible value 1, 0. So we can use vector B. For x-axis. So we have to find the projection of vector A on this vector B. So for that we can use the formula for scalar projection. And the formula is so this is the formula for scalar projection, and for this formula the length of vector B doesn't matter. So we could have used 0.2030 or any other point, we would have gotten the same answer. So this is an important concept you need to understand and memorize about projections. Now we can sub in the vectors. So vector A is 2, 3 dot 1, 0 divided by the magnitude of vector B, which will be the square of the components, and then we add them and apply square root to the sum. So in the numerator we have to do the dot product, so we multiply the x components and y components. And in the denominator, 1 square plus 0 square is equal to 1, and square root of 1 is 1. So I got 2. So the scalar projection of vector A on x-axis is 2. Now we can find the vector projection. So the formula for vector projection is A dot B over square of magnitude of vector B times vector B. Now we can sub in the values. So vector A is 2, 3 Now the magnitude of B we calculated in the scalar projection as 1, and vector B is 1, 0. Now we can do the dot product in the numerator. So 2 times 1 and 3 times 0. So in the numerator, we just get 2 times 1, 0. So we have to do scalar multiplication here. So we get 2, 0. So this is the vector projection of vector A on x-axis. Now we can do part B. In part B, we have to find the scalar and vector projections when vector A is projected onto the y-axis. So first, we'll write a vector that represents y-axis, and that can be vector B, and it can be the position vector for any point that lies on the y-axis. So we'll have to consider only the positive part of y-axis because that's the part of y-axis in quadrant 1. And it can be any point 1, 2, 3, 4, but we should use the easiest point, which will be 1. So the vector will be 0, 1. The length of this vector B won't matter because the projection is on vector B, so the length of vector B won't matter. Now we can start with the scalar projection on this vector B. So we can use the formula. Now we can do the dot product in the numerator. So 2 times 0 plus 3 times 1. And in the denominator, we just get 0 plus 1, which is equal to 1, and square root of 1 is 1. And in the numerator, we just get 3. So this is the scalar projection of vector A on y-axis. Now we can find the vector projection. So we'll start with the formula. Dot product in the numerator is equal to 3. We calculated that for scalar projection. The magnitude of vector B is just 1. So 3 over 1 is just 3. And now we can do this scalar multiplication. So we multiply both components by 3. So we get, so this is the vector projection for vector A on y-axis. So this should be the final answer. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.